Good morning, everyone.
Good morning, sir.
Okay. So listen, this is a continuation of the last lecture, block over block. So already we have completed how to find maximum force required to move objects together. Yes or no? So here this type of problem we considered already. What is this? Now here you have a block like this. If a block have like this, okay. So suppose this is your block B and another block you have block A. So this is your block A. So mass is MA. This is your block B. Mass is MB. They are lying on the horizontal floor, right? So what we have discussed here, if a force is applied here, F, yes or no? Force is applied F here, then what should be the maximum value of this force so that both the objects will move together? Yes or no? So what is the maximum force we got? Now maximum force we got mu G into MA plus MB. MA plus MB. Okay. Remember this force is applied to the lower block and their friction was there here mu and this surface was smooth. This surface is what? Smooth. Yes or no? F max equal to mu G into MA plus MB. This is the maximum force you can apply on this second block, that MB block, B block, the lower block you can tell, so that both the objects will move together. This one we derived. And after that we told two conditions. What are conditions? Take here suppose case 1. Case 1, what is that? If F is less than F max, F is less than capital F max, okay, then what will happen? Then both the objects, both the blocks will move together. This is the condition we got. Yes or no? Now here if you analyze, what will be their acceleration? Now acceleration of the block, acceleration, that is basically common acceleration. What I can tell? Common acceleration. What is that common acceleration? A subscript I can give C. Common acceleration. So what is that common acceleration? The total force applied capital F divided by M1 plus M2. So F is the applied force and F max is what? Is the maximum force required to move the objects together. And if F is less than F max, then only objects will move together. So when this type of things are there, first you check objects are moving together or not. Okay. Situation you understand. This is what basically, now this is your maximum force required to move two blocks together. Okay. So now if there F condition coming, F less than F max coming, then what you can tell? Now both the objects are moving together. Common acceleration will be, total force is how much? F. Total mass is MA plus MB. So common acceleration is what? F by MA plus MB. Yes or no? And here another thing we discussed. What is that? Now static friction. What is the static friction value in this case? Static friction. So static friction will be MA into AC. MA into upper block into common acceleration. This is the static friction. Because this friction will help to move this mass MA. So that is the reason we are taking. Okay. Because this friction force, this MA will move with common acceleration SC, and for this object only the friction is static friction F. So F value will be nothing but what it is. This F value is nothing but it is MA plus SC. Yes or no? This is what idea you are understanding. Clear? So this is static friction F, I can write. It is MA into SC, common acceleration. So this formula you remember please. This formula. If both the objects are moving together. Have you written this? Yes or no? Now next thing. If F is becoming greater than F max. F is becoming what? Greater than F max. If capital F is greater than F max, that means your applied force. This F is nothing but what? Again and again I am telling. The applied force on the lower block. if applied force is greater than F max, what is F max? Here you have to find with this formula. Already we have derived in the last video. So F greater than F max, then objects or blocks will move separately. Blocks will move separately. Yes or no? If they move separately, then they will have separate acceleration, different acceleration. So what will be the different acceleration? Listen here. Now first you take MA block, A block you take. On that, what is the force acting? Now frictional force, which is what? Fs max, which is nothing but mu s times, okay, Ma into G. This is the maximum force is acting on that, and its acceleration is what? A1, or acceleration A1 you consider. Mass is Ma. So now if acceleration I want to write, what I'll write here? Fs max divided by what? Ma or M1, whatever you take. If this is one block, na? So acceleration is nothing but this much, and this value you can substitute there, no worries. Okay, this value you can substitute there. So when F is greater than F max, then our blocks will move separately. So first to consider for first block, if this moves separately, on this what is the force acting? Now maximum this much force will act, friction force. With that friction it will move with some acceleration. So for MA this is the acceleration. Have you written or not? Clear idea? Okay. Next listen. For B block we will try to find what is the acceleration of B block. A block, did you understand? For A block only friction is responsible for motion, that's why here friction is taken in this forward direction. Okay. But for B block if you will see, for B block, what we have done here? If a B block free body diagram will do, now friction will act in opposite direction, which is Fs max only, Fs max, and here force is acting F, it is moving in this direction with the different acceleration, which is A2. Now A2 is nothing but how much it is? Now it is F minus Fs max divided by what? Mb. Okay, so this is your acceleration for the second block. Clear? So lower block acceleration is this much, and Fs max value you know already. You can calculate with this formula. And always remember here friction is between A and B. So whatever frictional force will come, it will depend how? Now static friction value, mu value into mass of A, upper block mass into G. Clear? No doubt here? Okay. So this is what we understood already. If F less than F max, objects will move together. If they move together, what will be common acceleration and what is the static friction? And if they move separately, then what is your acceleration of each block? Now A1, A2 you have to find with the free body diagram in this formula. And the next, if you want to find what is the friction between, suppose I am asking what is the friction between A and B. Okay, two blocks, what is the friction? Now that will be nothing but it will be Fs max. In this condition, in case 2 condition, the maximum friction nothing but that is the friction between A and B. Clear idea? Now try to understand this and note it down. Clear? No doubt? No doubt is there? No? Right. Now based on this one question we'll see. Okay, actually here we are discussing with the mass MA, MB like that. Yes or no? MA, MB like that we are discussing and we are getting some formula and we are telling in this way you can find. Now check with the question, how you can solve with question. Clear? So here particularly value will take, this all values will be given and this value also will be given. So now we'll try to find what is F max and we'll check first. You have to check bodies are moving together or not. Okay, if bodies are moving together, this is the formula you have to apply. If they are moving separately, then this is the formula you have to apply. Okay, clear? Now let's see one question here. So this is the one question given here, one 10 kg, 20 kg, 2 blocks. Okay, so one block is over another block. Now what is the static friction between them? 0.4. And this surface is what? Smooth surface. This surface is smooth. And next listen. Find acceleration of each block, friction between 10 kg and 10 kg. This is the question. You have to find this one. Clear? Now, what is your formula? F max. That one you first you try to apply. But before that, here one force is given. What is the force given here? Tell me. 90 Newton. So here one force is given 90 Newton. So if force is given only, it can move, right? Yes or no? Or it cannot move now? We can analyze from the formula. So first of all, 90 Newton force is given. Now, we want to find what is the acceleration of each block and what is the friction between 10 kg and 20 kg. Clear? Now, when force is applied to the lower block, what is the maximum force? That one you find first. What is the maximum force required to move the together? What is the maximum force? What is the maximum force formula? Mu into G into MA plus MB. This is the formula already you studied, MA plus MB. Now what we'll do here? Now mu is nothing but, how much it is? 0.4. G value 10. A value 10. B value 20. Yes or no? So 0.4, 10, 10 plus 20. So how much it will come, check? This is 4 into 30. So 4 into 30 means 120 Newton. That means your F max force, your maximum force required to move together is 120 Newton required. Yes or no? That means if less than this also I will provide, they will also move with together. That means here whatever conditions you have written, you check here. Here if F less than equal also you can write. No risk. Less than equal, no risk. Okay, I told you if F less than F max. Yeah, this is applied force, this is the maximum force. Now see here. Here applied force is 90. Maximum force is 120. Okay. Now your F is coming less than F max. That means these objects will move together. If object moves together, then they will have common acceleration. So directly common acceleration you can find. So now let me write I. So here you can write here. Here applied force. This one you consider as applied force F is less than F max. So blocks will move together. Separately they will not move together. Blocks are moving together, then what is acceleration? Acceleration of each block. What is that acceleration basically? That is your common acceleration. Common acceleration is what? F by ma plus m. Now common acceleration is nothing but F is 90, A is how much? 10. A is 10 and B is 20. So S is coming how much, tell? Say 90 by 30. 90 by 30 is how much? 3 meter by second square. Clear? So as both the blocks are moving together, then common acceleration directly you can find how much that is? 3 meter per second square. Clear? No doubt here. Why did I found this acceleration, common acceleration? Because they are moving together. How I identified they are moving together? Now F applied force is less than maximum force required to move together. Yes or no? So here maximum force I calculated with this formula. Already I derived this in the last video. So you can check that. So now what is happening here? Now you are getting what? You are getting your acceleration of each block. Now next is friction between 10 kg and 20 kg. That formula also given. What is the friction between 10 kg and 20 kg? Friction between 10 kg and 20 kg. Friction between 10 kg and 20 kg, if you will check, how much will be this one? Tell. This friction will be nothing but mass of upper block, MA, into common acceleration. This is your A block, right? You consider this is your A block, this is your what block? B block. Now tell, what is this acceleration MA? Acceleration MA, acceleration is 3 and mass is 10. So 3 into 10 is nothing but how much? 30 Newton. Yes or no? This is the friction between 10 kg and 20 kg. Clear? Got the point? Okay. So this is all idea you should understand. So take one situation and try to understand how to find acceleration and friction if both the blocks are together and force is applied on one of the block. Okay, and in this particular case it is applied on the lower block. Clear? Now we'll understand if this applied force is acting on the upper block, then what will happen? Okay, what is maximum force required, and what they will move together or not, how to identify that one we'll try to see. Okay, so we'll record in the next video. Thank you. Like and subscribe with the NEET Academy channel.